Alright, can everyone hear me? Alright, hello everyone. This is not Resale Wars. Sorry about that last minute change. This is, yes, Bash can get uglier, using Bashfuscator to generate complex, layered Bash obfuscation. This is a talk about diving into the depths of Bash, everything it's capable of, and just generating some really ugly commands. So, first, who am I? My name is Andrew LeFevre. I am a junior at Liberty University, around Central Virginia area, so 4 or 5 hours from here. I am pursuing a bachelor's in computer science, and I am somewhat frequently on Twitter and definitely frequently in GitHub, both under the handle Cap'n Spacehook. That's a long story, but so motivation. Why would I study, or why would I try to delve into research of Bash, obfuscating Bash, right? Well, Daniel Bohannon from FireEye Mandiant, he's given numerous talks on PowerShell obfuscation, and recently CMD.exe obfuscation, great stuff. Released invoke obfuscation, invoked obfuscation. So he's just really showing us that PowerShell obfuscation is proven to be effective by attackers, right? Like, I mean, yes, PowerShell is dying now in terms of offensively. Like, Microsoft is, tons of logs and everything, like tons of insight and optics into that. It's great, it's amazing. But for a while, and still even some now, attackers are really leveraging the powers of PowerShell and using it to obfuscate. Invoked obfuscation helped defenders deal with PowerShell obfuscation by providing them a tool through which they could generate thousands and thousands of just different, varied, obfuscated samples they can use to test their detections against. And so why is Windows getting all the love, right? I'm more of a Windows guy, right? I love diving into Windows internals, all of that, but I'm like, I don't know if I can do any more research on Windows. Like, what about Linux? What's there on the Linux side? So, Bash is one of the most widely known and used shells, right? I'm thinking like, okay, PowerShell on Windows, what's the equivalent on Linux? Bash, right? Sure, there's tons of other shells. You got C shell, corn shell, fish, all that stuff. But if you think of the one shell that your system admin, or you, if you have a Linux system, you most likely have used at some point in time, it's Bash. It's used by sysadmins and attackers alike, for post-exploitation stuff. If you drop on a Mac OS system, chances are there's Bash. If you drop on a Linux system, like Fedora-based system, on some of the BSDs there might not be Bash, but I'm mainly going to be focusing on Linux, as we'll cover later. And then again, at the time when I started, around July or August of last year, hardly any research on Bash obfuscation at the time existed. There is a small amounts now, which I'll go over, but some of it came about right as I was starting to pursue, which is pretty cool. But it's only really a few tweets. There's nothing really formal, anything. Plus, I just wanted a good excuse to learn Bash. I'm like, hey, what better way to learn the language to learn to obfuscate the crap out of it, right? So, some Bash obfuscation in the wild. This is a very simple sample that uses base 64 and XOR to encode the payload. It runs through simple for loop to base 64, decode it, and then XOR decode it as well. It's pretty simple. This is found by Dissect Malware. I'll have the slides of everything, so you can go find this if you want. But as far as actual obfuscated samples, there was very few I could find in the wild, and this is one of them. So the reason for me doing research was very different than Daniel Bohannon's. I wasn't starting doing research because attackers are already abusing and obfuscating Bash. I wanted to think, okay, like, if I want to stay one step ahead of them, if I want to go on engagements as a red teamer, which I'm not, student, but in the future, if I wanted to bring something to the table that's new, or, help defenders out proactively, hey, what could attackers be doing? Like, why don't we proactively start building detections against this? Nothing really uses this, and they could obviously pretty easily obfuscate Bash. So, and as far as like actual tools that are out there to obfuscate Bash, the Metasploit actually has some encoders for shell scripts. They have like 3 or 4. I haven't really used them much, but looking in the comments, some of them they pretty much blatantly say, don't rely on this, it may break. As far as I can tell, it's pretty much only used for hiding blacklisted characters if you're passing through a WAF, you know, you don't want, like, blacklisted characters getting through there, stuff like that. It's not for robust obfuscation, like frustrating analysis, like really slipping past detections. It's more just like a quick and dirty try it if it works, right? And then there's these bad boys I discovered actually after I finished a lot of my research, which is kind of sad, but we're going to refer to them as Bash F to just keep this family friendly. Two of these seemingly almost identical, pretty close repos in GitHub that basically it's akin to BrainF, the language, or JavaScript's F, what you can do with that. Basically just takes input bash and spits out a version of it with only special characters, which I ended up doing in a different way after I learned, I learned about these after, which is kind of sad about, which helped me, but these do exist also. Here's a little sample of what they can do. Some fun stuff, but you'll see more of that later. But yeah, they just use bash commands entirely special characters. There's no alphanumeric in there at all. Well, except for the very beginning there. There's a little bit there, but so let's dive into it. Let's go over some basic obfuscation techniques you can do with bash, right? How do we come up with obfuscation techniques? Well, we make changes to the command that bash ignores. So you pepper the command or just manipulate the command in such a way that when bash is parsing it, they're almost kind of like no-ops in like assembly or something like that. It's just kind of just throwing a whole peppering, like an assembly thing with a bunch of no-ops around it. So like when bash is actually parsing and executing it, it just ignores that stuff. But if you're looking at it, it obviously breaks it up. The more drastic, the better. So let's start with the fairly common command you might see an attacker use at post-exploitation, right? They're getting in your system, they're going to cat your etc password, see what users are on the system, they're going to grep, attack E, they're going to see basically, hey, of all these users on here, which users have a login shell? Which users can I log in as, potentially like, escalate privileges to, lateral move, whatever, right? Maybe from a different box, like, so this is a somewhat common command you might see attacker using. So how can we start breaking this up? How can we start obfuscating this? Well, one of the first things we can do is we can just randomly escape a lot of these different characters. And what bash does here is, unless they are special characters that have a special meaning, for example, the $, it just means, like, hey, like there's a variable starting here, bash completely ignores this. So when it's parsing this, it'll just basically just throw those away, and it'll say, okay, \c, \a, that's nothing, so I'm just going to take those out and just ignore you put those there. So, perfect for obfuscation. So yeah, so these characters like the asterisk, the bang for history expansion, asterisk for globbing, and the $sign for variables and parameter expansions. If you escape those, they will have a different meaning, but if you're just escaping most built-in or command names, it'll almost always do nothing. The caveat here is that technically in Linux, which I was surprised to find out, you can have a file name, which in turn could be a binary you're calling. It can contain any character except the null byte. So you could potentially you can't escape any character in any command, because it could contain stuff like that, but that's just something to be aware of. But most stuff, obviously, it's human readable. It's just using alphabetical stuff, so binary built-in function names can be escaped safely. Aliases cannot. I still don't know why, but you can't do this to aliases. It'll break stuff, but everything else is fine. Another thing you can do, ANSI C quoting. This is a really fun one. So basically what happens here is bash, this is very effective for obfuscation. You can, what this is used for though, what this is intended for, it's intended for basically inserting normally non-printable characters into your script. So stuff like a vertical tab, or stuff like, I don't know, there's a bunch of extended ASCII, like weird stuff, like from ASCII, like the 0 or the first or 0th value down to like the 20th or something. There's a lot of weird characters in there that you never type. They're not available on your keyboard. But if you know the octal, or yeah, how useful is that? But if you know the hex, octal representation of those codes, the Unicode, like the hex value, like of size 4, So basically it's like a lowercase u 000 or whatever it is. Or if you know the hex 8, like a size 8 version of it, then you could basically insert those non-printable characters in there. But it doesn't just work for non-printable characters, it works for anything. So right there, I'm just using 63, 61, 74, which correspond to CAT and hex, like the hex, they map to the ASCII values, CAT and hex, but you can use octal, hex 64, whatever, right? But you can mix and match syntax types for some really nasty stuff. So here we have octal in there, 141, that's just which corresponds to A, you know, the ASCII representation. That's also responds to C. Like, you see what you can do here, right? So what's also cool is, I don't know if you can see it, that's pretty dark, but that C right at the beginning of there, you can shove stuff in there, like, okay, so like, you can like shove like normal characters in there to just kind of mix it up. So if you're writing like a naive parser for like this type of obfuscation, you might go, hey, like, you know, like, I see, go back one here, like I see like U0063, like, you know, 141, X74, like those are all, you know, either hex, octal, or Unicode representation of those characters, right? But then you see a C. What is that? What is that doing? I don't exactly, that's in the bash manual, whatever, it doesn't specify you can do this, it's just one of the quirks of the parser, one of the many. But you can just throw, like, normal, you know, unobfuscated characters in there, and bash will just interpret it as a C, and then just parse the A and the T after it. So you can randomize that and just really there's a lot of possibilities with that. Throwing the T on the back, throwing an A in the middle there. The only thing you need to be careful of is you don't interfere with the ANSI C quoting syntax, which is, for example, the octal, it's most of 3 digits. So if you have like, or say for hex, if you have like right here, X74, I think, or yeah, I do a T here. But if you threw something that would correspond in hex, so if you say you threw an A or something after that 74, that would actually mean something different, or potentially, because bash will then interpret that as the actual hex thing. So there are limits to what you can do with this, but if you're staying within the ANSI quoted syntax, it's the bash manuals where you can find that stuff, but you can obfuscate that pretty well. Yeah. You can also quote random characters. This is just the same thing, like if you just want to quote random things, like bash is just like, hey, you're quoting this, but you don't do anything in here, so I'm just going to ignore that, right? You can use single or double quotes. Something to keep in mind when using double quotes, just strong versus weak quoting in bash in general. If you're just quoting random, non-special characters, it won't make any difference, but there is a big difference between double quoting and single quoting in bash. You just have to be aware of that. It's basically the same principle. It's a little different, but like if you're just quoting like some arguments or commands, it's the same principle as obfuscating with forward slashes, just escaping stuff. You're just escaping stuff that doesn't need to be or shouldn't be escaped, so bash is just like a no-op, basically. You can also do string concatenation. So what's happening here is bash would, by default, if you have multiple strings just right next to on top of each other, bash will internally, just when it's parsing, concatenate them all, right? So right here, we just shove an empty string in the middle of grep. So bash, when it's parsing, it's like, hey, we got a escape G, okay, it's just G. We got an R, we got an empty string, and we got a E, and, quoted P. So the slash goes away, the quotes go away, the empty string, it's just like, okay, we're just gonna, concatenate that string with the gr and the ep, and just grep, right? So that's just how it works. It's really nice. You can see pretty quick how you can, all these little things by themselves don't do a lot, but when you start mixing them all together, it can be really, really nasty. Bash automatically joins JSON strings. And this is a very interesting one. If you've ever used bash for any extended point of time, you should know, or I'm sure you've used subshells. Basically, what subshells are, it's you throw a command in the subshell, and the subshell returns the result of that command back to the top layer, right? So, but if you just have an empty subshell, bash will just basically interpret that and be like, hey, okay, we're gonna evaluate the expression inside of the subshell, and it's nothing. So it basically returns an empty string, then we go back to what we just learned, it just concatenates that to nothing. So, but empty subshells treat like empty strings because they return empty strings essentially. So bash is, there's almost like a no-op. It does do some execution there. So if you throw a bunch of them in there, it'll, still try to execute and parse them and everything. So there will be increased runtime. But as far as actually like functionality of your command, it won't change it at all. Any amount of space can be used in there. It's still empty. I mean, there's no command in there. It's just space. So obviously space in bash does nothing. So, or for most places, like if it's just, just a command, if you just enter a whole bunch of spaces and press enter, bash is going to do nothing. So you can get creative with it. You can use the alternate syntax, the old graves, the deprecated graves. That can be fun if you're doing a lot of single quoting, or single quote stuff, because they just blend in really well. And, oh no, rmtac/rf/, right? That's terrible, right? But if you notice up there, we have a pound, that's actually a comment. It's a comment inside of a subshell. So bash parses that, and it's like, hey, look, it's a comment, and then we're going to see if there's anything after it. No? Okay. Basically the same thing as an empty subshell. You can throw anything you want in there, right? You can call out, hey, my Twitter handle is this, like whatever, mislead commands, like you can put anything you want in there in a subshell that's commented out, doesn't do anything. So that you can really mislead people if they're just glancing over it, right? That is pretty interesting. So one of my favorite things I discovered about bash obfuscation that you can do with it is the special characters, or special variables, sorry. The $@ I don't know what to refer to them as. They're the $, asterisk variables. What they allow you to do, they actually contain the value, well, their value is the empty string in an interactive shell because, because they actually contain the arguments of what bash was called with. So if you're in an interactive shell, you just call bash, right? It's just nothing. Even if you do like pass bash some arguments in an interactive shell, like okay, bash like tacx or whatever, it'll still evaluate to nothing. But if you have a script that has a shebang with bash and you pass the script some arguments, these will actually contain the arguments you pass to bash, right? But their value's an empty string, right? So based on what we learned, we can surmise that it's free real estate. We can throw these in here. They'll just be parsed out, have some fun with them. So we can just pepper these in here. Same thing as everything else we've been doing. They'll just be taken right out by bash. And they hold their arguments to current version bash called with. But there's even more that can be done with these magical variables, right? Has anyone here ever heard of or used parameter expansions in bash? Anyone? Yeah, one person, two people. They're not very well known, but I'm not going to go over all these. This is just for reference, but these are just some, like a half or less of the parameter expansions bash has to offer, but these are the parameter expansions you can actually use with, this command or these variables to basically just obfuscate them. And so you can do stuff like this, and like they're basically manipulating the stuff inside of the variable. So like the first one is just saying, hey, everything inside of, the first one, it's just saying, hey, uppercase everything in there, but it's an empty string, so you can't uppercase an empty string. It still results in an empty string. So you can do this kind of stuff. You can insert garbage in here, like what the first one is saying is just say, hey, everything, like, it's searching for, that string in there, which it's not going to find, and then it's trying to remove it, but since it's an empty string, it doesn't do anything. Again, so you can just put almost whatever you want in there. You just have to be careful to not put another, because it's parameter expansion, you can't put another, right brace in there. It'll terminate it early, but you can just throw a lot of garbage in there. So how can we make this better, right? We have all these obfuscation techniques, but if we want to have some really robust obfuscation, if we want to, be able to generate this stuff, how do we make this better, right? We can automate. We can just, write tools, scripts. Everyone loves automation to automate this process. We can mix and match obfuscation techniques, all this stuff like we were doing, but lots more. We can create a framework for writing obfuscation techniques easily. Everyone likes frameworks, right? Not if you're given to you, sure. But not everyone likes writing them, but they're useful, right? And so introducing Bashfuscator. This is a tool I wrote. It's almost 4,000 lines of Python 3. It takes in bash commands and just mangles the heck out of them. Just just shoves you back massive commands you can tweak a lot, and just gives you just a whole bunch of stuff that does the same thing but looks different. So a little running short on time here. So there's 5 different types in here. Basically, all you need to know is encoders, they just encode bash commands, right? Compressors, they compress your command, make them a lot smaller. Command obfuscators. What's that? 10 minutes, okay. The command obfuscators basically take your command just using simple stuff like rev or stuff like that, just reverse your command. String obfuscators just use a bunch of binaries like core util stuff to just mangle stuff, Token obfuscators obfuscate using bash functionality, right? But I know you guys, you want to see this. Like, what do I have here, right? So I'm going to try and do a live demo. I know this never works out very well, but we'll see. There's no internet access or anything, so. Okay, if I can enter my password. Oh, I don't know why that didn't show there. Okay. Just log in here. Alright, so the command is Bashfuscator. We can just enter the same thing we did earlier. Oh, is that big enough right there? Okay, so we're going to enter here cat etsy password pipe grep tac e bash, and basically there are right now 12 different obfuscation modules, so I'm just going to choose one. So first I'm going to use string hex hash, which is a module written by one of the members of the audience here, Elijah Barker. Basically, yeah, so scroll up and see that. So it's really big, so it takes up it's a lot. If you make the screen smaller, it's it'll fit in the screen mostly. But yeah, you can see right here it's pretty big. So does this work, right? Does it work? Let's test it. There you go. Those are the users on my system that I have a login shell. And if we want to copy to a clipboard, we can just say, hey, just copy to clipboard. And because it's in your clipboard, I won't show you the whole thing because it's right there. So if we want to paste this in here and execute it, there it is. You can copy that, throw in your payloads, whatever, right? So, but let's do a little bit more of that, right? So the great thing about automating this stuff is you can stack stuff on top of each other, right? So you have string hex hash. There's another one, token for code. This basically here. Turn off mangling. That just makes it a lot worse. It basically just takes your command, splits it into randomized array, and basically just builds out your command from that array. Don't really have time to explain it fully, but Daniel Bohannon actually introduced this technique and invoked Obfuscation, but I just ported it to Bash. You can do a lot of stuff, right? And then we have this is my favorite one. This took me a month to do correctly. Special character only. So this is cat etsy password pipe grep e bash, and only entirely special characters, right? So does this work? This should not work. Will it work? Yes. So let's copy that. Let's just give you a taste of what it looks like. So this is entirely special characters. There is not a single alphanumeric character in there, right? And the great thing about this, I don't know if I have time to show you, if anyone's familiar with Bash's debug mode, it'll take commands and basically just say, hey, step by step, everything that happens and print out, what's going on to the screen, right? If you run this in debug mode, it will break. And basically, it does crazy stuff on purpose, generating bash errors, sending the standard error to variables, and then processing them. It's just a mess. If you want to learn how it works, talk to me after. I spent a month writing it. It was just a mess. But you can do a lot of fun stuff. So it's a last minute quick demo. We can take that, we can compress it, since it compresses really well. We can throw another thing on here, token for code. And we have this monstrosity that's 121,000 characters, right? Let's compress that again. And will this run? Let's test it. There you go. 4 different layers, 2 layers each compressed, bash obfuscation. You can stack, mix and match stuff as much as you like. So there you have it. Live demo worked. How's that? And then, real quick, if you want to download Bashfuscator, it's on GitHub on github.com/Bashfuscator/Bashfuscator. I'm on Twitter, GitHub as Captain Spacehook, and didn't have time to show it, but two people in the audience right down here, Elijah Barker and Charity Barker. Elijah developed a bunch of the different obfuscators, crazy stuff. It's been a while since I looked at them. I understand most of them, but it's just crazy stuff. And their Charity developed a bunch of size and time graphs, which are in a dev branch of documentation, but will be in soon. So basically, you can pick any of the dozen obfuscators and see, hey, given this size of input, how large will my output be? Or given, this size of my output, like how much more time will this obfuscator increase my runtime? Stuff like that. It's great. And Nathaniel Hatfield, who's not here, wrote a module for Bashfuscator. So if you want to ask any questions, my DMs are open. Trey and Elijah are both on Twitter. You can ask us anything if you want to, whatever. So, yep. Thanks. And also thanks to these people from some way or another helped me in research the depths of Bash. It's a frustrating thing, but yeah. Thank you very much, everyone.